Welcome to The Explainer. Today, we are diving deep into the seriously smart technology that makes modern search work. And it all starts with a problem I know you've had.
We have all been there. You type something into a search bar, you hit enter, and the results that pop up are just not it. It's a classic, totally frustrating experience.
And this shows you exactly why that happens. Look at the left side. An old-school keyword search just sees jaguar and speed, and, well, it gives you a fast animal. But look at the right. A smarter search, a semantic search, gets the context. It understands you're probably asking about a car and gives you the car's top speed. Now, that smarter way of doing things has a name.
It's called semantic search. And honestly, the best way to think about it is like having this super smart librarian. Not one who just finds books with your exact words in the title, but one who actually understands what you're trying to figure out and points you to the best information no matter how you ask for it.
So, what's powering this smart librarian? It's a system built to understand two really important things: your intent, what you actually mean, and the contextual meaning of the words you use. This is the big leap, right? It's what separates a machine that just matches words from one that truly gets what you're saying. So that leads to a pretty cool question. How in the world do you teach a machine, which really only speaks the language of numbers, to get all the subtle shades of meaning in our human language? Well, the answer is actually found in math, and that answer is something called vectors. Now, in this case, a vector is really just a list of numbers. But here's the brilliant part. That list of numbers acts like a unique numerical fingerprint for a word, or even a whole sentence. It captures its meaning in a language the computer can actually work with. And this whole numerical fingerprint idea is so powerful because sentences that mean similar things get similar fingerprints. So if you look here, the fingerprint for the latest iPhone has a great camera. It's going to be mathematically close to other sentences about phones and tech. But it's going to be really far away from the fingerprint for a sentence about cars or politics. The machine can literally measure the distance between ideas. It's wild. Okay, so to make all this a reality, engineers usually turn to a killer combo of tools. Let's meet the dynamic duo that makes this kind of smart search happen: USE and FAISS. Just think of them this way. You've got the Universal Sentence Encoder, or USE. That's our translator. Its entire job is to take our words and turn them into those numerical fingerprints we were talking about, the vectors. Then you've got FAISS. That's FAISS, which stands for Facebook AI Similarity Search. FAISS is our super fast librarian. It takes all those fingerprints and organizes them into a library so it can find the closest match to what you're looking for in a flash. And when they work together, the process is actually beautiful in its simplicity. So first, USE translates your search query into its own vector. Then FAISS takes that vector and zips through its massive pre-sorted index to retrieve the vectors that are the closest mathematical cousins. And boom, those matches are your search results. All right, the theory is cool, but let's see how this stuff actually gets built. We're going to walk through how to create a real semantic search engine from scratch, using a classic dataset called 20 newsgroups, which is basically just a big collection of real, messy human conversations. Let's get our hands dirty. Okay, first things first, and this is maybe the most important step: pre-processing. You have to clean up the data. You've got to get rid of all the noise that could throw the model off. We're talking email headers, weird punctuation, extra spaces, so you're left with just the pure, meaningful text. And this is the actual code that does it. You don't even have to be a programmer to see what's going on here. This little function, pre-processed text, is like a tiny cleaning robot. It just systematically goes through and strips out all that junk we mentioned, leaving only the good stuff behind. And wow, the result is so satisfying. On the left, you've got the raw, messy post with all the headers and junk. And on the right, clean, focused text that we can actually use. The difference is just night and day. So now that our text is all clean, we bring in our translator, US. It's time to read every single one of those posts and give each one its own powerful numerical fingerprint. And here's the code that does the heavy lifting. This embed text function basically just calls up the pre-trained universal sentence encoder. We feed our clean text in, and what comes out on the other side is a vector, that list of numbers that represents the actual meaning of the text.
All right, for the final step of our build, it's time to bring in our librarian, FAISS. We have thousands of these vectors, right? One for every document. Now we need to organize them so we can search through them efficiently.
And you know what's crazy? The code to do this is incredibly simple. We're just telling FAISS to create a basic index that knows how to measure distance. Then, with one command, index.add, we just dump all of our document vectors into it. And just like that, our library is built and ready to go.
Okay, everything is built, the text is clean, it's vectorized, it's all indexed. This is it, the moment of truth. Let's give our brand new search engine a real test with a query that would totally stump a simple keyword search.
Here's our query: discussions on religion and atheism. Now, think about that. This isn't just looking for keywords. It's asking for a concept, for a type of conversation. This requires a real understanding of the topic. So, what's our little engine going to find? Look at that. The top result is absolutely brilliant. The text is talking about a personal belief system, a mimetic virus, the difference between religion and religion. It doesn't even have the word atheism in it, but it has perfectly captured the semantic meaning of what we asked for. It understood our intent, not just our words. This right here, this is semantic search doing its thing. And that really just leaves us with a pretty powerful thought. We've just seen, step by step, how we can teach a machine to go beyond just words and actually understand meaning. It really makes you wonder, if this is what search can do today, what's just around the corner? What comes next?